In the United States, the National Electrical Code, known as the NEC, serves as the primary set of electrical safety regulations. It is important to note that the NEC does not mandate ground fault interrupter, or GFI, protection for extension cords. The NEC does, however, require GFI protection in specific locations. These locations include outdoor receptacles, kitchens, bathrooms, and garages. Typically, extension cords are not intended for use in these designated areas. While GFI protection is not a mandatory requirement for extension cords, it can be a beneficial safety precaution in preventing electrical shocks. GFI outlets work by detecting current flowing back through the ground wire instead of the neutral wire. When this imbalance is detected, the GFI trips the circuit, preventing potential electric shock hazards. It is worth noting that extension cords can occasionally trigger GFI outlets due to minor current imbalances, leading to what are known as nuisance trips. These nuisance trips can occur due to several factors. Firstly, faulty cords or connections can cause these trips. Secondly, high-power tools or appliances can contribute to the issue. Thirdly, other devices that generate electrical noise can also be responsible. Despite the potential for nuisance trips, it is essential to acknowledge the substantial safety advantages that GFI protection can provide for extension cords. GFI protection offers several benefits. Firstly, it helps prevent electric shocks. Secondly, it reduces the risk of electrical fires. Thirdly, it safeguards sensitive electronic devices from potential damage. To minimize the occurrence of nuisance trips when using extension cords with GFI, consider the following best practices. Firstly, ensure that cords and connectors are well maintained. Secondly, avoid overloading the cords. Thirdly, keep the cords away from moisture. Fourthly, opt for GFI outlets or adapters that offer adjustable sensitivity settings. In conclusion, although GFI protection is not a mandated requirement for extension cords, it serves as a valuable safety measure to mitigate the risk of electrical shocks and fires. By adhering to best practices, it is possible to minimize nuisance trips and reap the benefits of GFI protection for your extension cords. Now let's delve into the specifics of how a ground fault circuit interrupter, or GFCI, operates and why it is such a crucial safety device, especially when considering the use of extension cords. A GFCI is designed to protect people from electrical shock. It works by monitoring the current flowing in the hot and neutral wires of a circuit. Under normal circumstances, the current flowing through these wires should be equal. However, if a ground fault occurs, meaning that current is leaking to ground through an unintended path, such as through a person, the GFCI will detect this imbalance and quickly trip the circuit, cutting off the power. The tripping happens very quickly, typically within milliseconds, which is fast enough to prevent serious injury or death. The NEC mandates GFCI protection in areas where electrical hazards are more likely to occur. These areas include bathrooms, kitchens, garages, outdoor locations, and near swimming pools. The presence of water and the potential for contact with grounded surfaces in these locations increase the risk of electrical shock. While the NEC does not specifically require GFCI protection for all extension cords, the use of GFCI protected extension cords or plugging extension cords into GFCI protected outlets is highly recommended, especially when using power tools or working in damp or wet environments. Extension cords are often subjected to rough handling, which can damage the insulation and increase the risk of ground faults. Using a GFCI in conjunction with an extension cord adds an extra layer of safety. Let's discuss the causes of those nuisance trips we mentioned earlier and how to prevent them. Nuisance trips can be frustrating, but they are often indicative of an underlying issue that needs to be addressed. One common cause is damaged or frayed extension cords. Over time, the insulation on extension cords can wear down, exposing the wires inside and creating a path for current to leak to ground. Regularly inspect your extension cords for any signs of damage, such as cuts, cracks, or fraying. If you find any damage, replace the cord immediately. Another cause of nuisance trips is overloading the extension cord. Every extension cord has a maximum amperage rating, and exceeding this rating can cause the cord to overheat and potentially trip the GFCI. Be sure to check the amperage rating of your extension cord and the power consumption of the devices you are plugging into it. Avoid using multiple high-power devices on a single extension cord. Moisture can also contribute to nuisance trips. Water is a good conductor of electricity, and if water gets inside an extension cord or an electrical device, it can create a path for current to leak to ground. Keep extension cords and electrical devices away from water, and never use them in wet or damp environments unless they are specifically designed for such use. Another factor to consider is the quality of the extension cord itself. Cheap, low-quality extension cords may not be properly insulated or may have loose connections, increasing the risk of ground faults. Invest in high-quality extension cords from reputable manufacturers to ensure that they meet safety standards and are less likely to cause nuisance trips. Some devices, such as older appliances or power tools, may have internal components that leak small amounts of current to ground. While this leakage may not be enough to cause a noticeable shock, it can be enough to trip a GFCI. If you are experiencing frequent nuisance trips with a particular device, try plugging it into a different GFCI protected outlet or using a different extension cord. If the problem persists, the device may need to be repaired or replaced. Let's talk about some best practices for using extension cords to ensure safety and minimize the risk of electrical hazards. Firstly, always use the right type of extension cord for the job. Extension cords are available in different gauges which indicate the thickness of the wire. For high-power devices, use a heavier gauge extension cord to prevent overheating. Secondly, avoid using extension cords as a permanent wiring solution. Extension cords are intended for temporary use only. If you need a permanent power source, have an electrician install an outlet. Thirdly, never run extension cords under rugs or carpets. This can trap heat and damage the insulation, increasing the risk of fire. Fourthly, do not nail or staple extension cords to walls or baseboards. This can also damage the insulation and create a safety hazard. Fifthly, when unplugging an extension cord, always grasp the plug itself, not the cord. Pulling on the cord can damage the wires and create a loose connection. Sixthly, store extension cords properly when not in use. Coil them neatly and avoid kinking or twisting them. Iron them up or store them in a dry place to prevent damage. Furthermore, consider using extension cords with built-in GFCI protection. These cords have a GFCI device built into the plug, providing an extra layer of safety. They are particularly useful when working in areas where GFCI protection is not readily available. Be aware of the different types of GFCIs. There are GFCI outlets, which replace standard outlets, GFCI circuit breakers, which protect an entire circuit, and portable GFCI devices, which can be plugged into a standard outlet. Choose the type of GFCI that best suits your needs. When installing a GFCI outlet, follow the manufacturer's instructions carefully. Be sure to turn off the power to the circuit before working on any electrical wiring. If you are not comfortable working with electricity, hire a qualified electrician to install the GFCI outlet for you. Test GFCIs regularly to ensure that they are working properly. Most GFCIs have a test button that you can press to simulate a ground fault. If the GFCI trips when you press the test button, it is working correctly. If it does not trip, it may need to be replaced. Pay attention to the color coding of electrical wires. In the United States, the hot wire is typically black, the neutral wire is typically white, and the ground wire is typically green or bare copper. When working with electrical wiring, be sure to connect the wires to the correct terminals. Use wire connectors to make secure connections. Wire connectors, also known as wire nuts, are used to join two or more wires together. Be sure to use the correct size wire connector for the number and gauge of wires you are connecting. Twist the wires together tightly before screwing on the wire connector. Consider the use of arc fault circuit interrupters, or a size, in addition to GFCIs. A size protect against arc faults, which are electrical discharges that can cause fires. The NEC requires a size in many locations, including bedrooms. Finally, stay informed about electrical safety regulations. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. You can find information about the NEC on the National Fire Protection Association or NFPA website. Electrical safety is a serious matter, and it is important to take precautions to protect yourself and your family from electrical hazards. By following these tips and best practices, you can reduce the risk of electrical shock and fire. Grounding is a critical concept in electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and energize the circuit. This helps to prevent electrical shock and fire. The ground wire is typically connected to a metal rod that is driven into the earth. This provides a direct connection to ground. All metal enclosures of electrical equipment should be grounded. This includes metal boxes, conduit, and appliance housings. Grounding ensures that if a fault occurs, the metal enclosure will not become energized, preventing electrical shock. Bonding is another important concept in electrical safety. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect metal parts together. All metal water pipes and gas pipes should be bonded to the electrical system. This helps to prevent straight currents from causing corrosion or creating a shock hazard. Surge protection is also important for protecting electronic devices from damage. Surges are brief spikes in voltage that can damage sensitive electronic components. Surge protectors work by diverting excess voltage away from the protected device. Surge protectors should be used on all electronic devices, including computers, televisions, and appliances. There are two main types of surge protectors: outlet strip surge protectors and whole house surge protectors. Outlet strip surge protectors are plugged into a standard outlet and provide surge protection for devices plugged into the strip. Whole house surge protectors are installed at the electrical panel and provide surge protection for the entire house. Electrical panels should be properly labeled. Each circuit breaker should be clearly labeled to indicate which circuits it controls. This makes it easier to identify and turn off the correct circuit in case of an emergency. Electrical work should be performed by a qualified electrician. Working with electricity can be dangerous, and it is important to have the knowledge and skills to do the job safely. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Permits may be required for certain types of electrical work. Check with your local building department to see if a permit is required before starting any electrical work. Inspections may also be required after the work is completed. This helps to ensure that the work was done properly and meets all applicable codes. Follow all applicable electrical codes and regulations. Electrical codes are designed to protect people and property from electrical hazards. It is important to be familiar with the codes and to follow them carefully. Common electrical code violations include overloaded circuits, improper wiring, and damaged equipment. Overloaded circuits can cause fires. Improper wiring can cause electrical shock. Damaged equipment can also be a safety hazard. Always be aware of your surroundings when working with electricity. Look for potential hazards such as water, metal objects, and overhead power lines. Avoid working with electricity when you are tired or distracted. Take breaks as needed to stay alert and focused. Remember that electricity can be deadly. Always take precautions to protect yourself and others from electrical hazards. By following these safety tips, you can reduce the risk of electrical shock, fire, and other electrical hazards. In addition to the general safety practices, consider the specific context in which extension cords are used. Construction sites, for instance, often require heavy-duty extension cords and temporary power distribution units that are specifically designed for the rigors of the environment. These units typically include built-in GFI protection and are built to withstand physical abuse. Similarly, outdoor events and gatherings often necessitate the use of weatherproof extension cords and GFI protection to safeguard against moisture and other environmental hazards. When using extension cords outdoors, ensure that they are rated for outdoor use and that all connections are protected from the elements. Consider using cord reels or cable organizers to keep extension cords neat and tidy, preventing tripping hazards and damage to the cords. Properly storing extension cords when not in use is crucial for prolonging their lifespan and ensuring their safety. Avoid leaving extension cords coiled up tightly, as this can cause them to overheat. Instead, loosely coil the cords and store them in a dry, cool place away from direct sunlight and extreme temperatures. Regularly inspect the plugs and connectors of extension cords for signs of damage such as cracks, loose prongs, or corrosion. Replace any damaged plugs or connectors immediately to prevent electrical hazards. Be wary of counterfeit or substandard extension cords. These cords may not meet safety standards and can pose a significant risk of electrical shock or fire. Purchase extension cords only from reputable retailers and look for certifications from organizations such as Underwriters Laboratories, or UL, or Electrical Testing Laboratories, or ETL. When using extension cords with power tools, be sure to follow the manufacturer's instructions carefully. Many power tools require a specific type of extension cord to ensure proper operation and safety. Avoid using extension cords that are longer than necessary, as longer cords can cause a voltage drop, reducing the power available to the tool and potentially damaging it. Consider using a power strip with built-in surge protection in conjunction with extension cords to protect electronic devices from voltage spikes and surges. Power strips provide multiple outlets and often include a circuit breaker to protect against overloads. When using power strips, be sure to choose one that is rated for the amperage of the devices you are plugging into it. Avoid daisy-chaining power strips together, as this can overload the circuit and create a fire hazard. Never remove the grounding prong from an extension cord or power strip. The grounding prong is there to protect you from electrical shock. If you are using an older outlet that does not have a grounding slot, have a qualified electrician replace it with a grounded outlet. Consider using a portable generator to provide power in areas where extension cords are not practical or safe. Portable generators should be used outdoors in a well-ventilated area to prevent carbon monoxide poisoning. Follow the manufacturer's instructions carefully when operating a portable generator. Finally, remember that electrical safety is an ongoing process. Stay informed about the latest safety tips and best practices, and always be aware of the potential hazards associated with electricity. By taking the necessary precautions, you can protect yourself and others from electrical shock, fire, and other electrical hazards.